Welcome to solverfy.
.78. Imagine we have a couple samples of natural carbon that contains the usual fraction of carbon-14. So we want to estimate about how long it takes until each one of them contains only one carbon-14 nucleus. So from section 30-11, the usual fraction of carbon-14 is 1.3 times 10 to the negative 12th. So not a whole lot. And because this is very small, we're just going to use the atomic weight of carbon-12 to find the number of carbon atoms in 72 grams, because, it's going to get lost in the noise if you try and use this anyway. You'd need way more digits than just 2, basically, in order for that to be meaningful. So then the number of carbons is going to be 72 grams of the sample divided by 12 grams per mole. Times Avogadro's number. And so this is going to be 3.612 times 10 to the 24th atoms. So the number of carbon-14s we'll have to begin with is 4.7 times 10 to the 12th. So you see, 12 orders of magnitude less, as you'd expect. Right. So then using the n equals n naught e to the negative lambda t thing we've been using all chapter, just go right ahead and write down an expression for the time this will take. So it's going to be 5,730 years divided by the log of 2 times the log of 1, the number we want to end up with, divided by 4.695, etc. Rounds to 6. Sort of less truncated than I wrote here. It doesn't really matter all that much. Times 10 to the 12th. And so we find that this takes 2.4 times 10 to the 5th years Now we do a similar thing with our 340 gram sample. We find that I'm not going to repeat all of the math, but the number of carbon-14s we get with 340 grams is going to be 2.217 times 10 to the 13th. And then the amount of time this takes in the calculation is exactly the same as before. And you'll notice something here. Which is it takes almost an indistinguishable amount of time, 2.5 times 10 to the 5th years versus 2.4 times 10 to the 5th years. And now the problem also asks us to, what does this tell you about the limits of carbon dating? And basically what this tells us is that times that are sort of on the order of 100,000 years are not accurately measured with carbon dating. Unfortunately, there are other various types of radioactive dating that can be used. But carbon-14 stops working by about the time you get to 100,000 years in the past.